Hi everybody. Today we're going to talk about the concept of mechanical energy. Now oftentimes things are going to have potential and kinetic energy. So if you think about anything being thrown up in the air or falling down from the sky, they all have kinetic energy because they're moving, and they have potential energy, gravitational potential energy, because they're off the ground. Now when an object falls, it speeds up, so it gets more kinetic energy. But what is lost is that potential energy, because now it's falling closer to the ground, it doesn't have as much height. So that potential energy is being transformed into kinetic energy. Now, what's important is that the sum of those two energies, so if you take potential energy and add it to the kinetic energy, that equals the same amount regardless of where the object is when it's falling. That energy of potential and energy kinetic combined is known as mechanical energy. So we have our potential energy, which was mgh, and kinetic energy, which is 1/2 mv squared. Now, if I was to show that analogy of something falling, if this is the ground and this is the object falling, right here it has mechanical energy of mgh plus 1/2 mv squared. That just means it has height. This is the height here. And it is moving. It has a velocity or a speed. And it's falling this way. Now, at this point, EM2, you have a different height. I'm going to call that H2. But it will have sped up. This is V2. So V2 is bigger than V1, obviously, and H2 is clearly smaller than H1. So what's interesting is that the total energy can't have been destroyed. The law of conservation of energy says that you can only transform energy. So the total energy from here, this EM1, equals the total energy here, because energy can't be lost. So EM1 equals EM2. So for Science 10, mechanical energy is always conserved. And this is a huge mathematical relationship in terms of answering questions. We're going to do several questions, practice questions, and hopefully it comes a little bit more clear. But another way of showing this formula for help for mathematical questions is that EM1 is the same thing as EK1 plus EP1. So kinetic energy 1 and potential energy 1. And EM2 is the same as EK2 plus EP2. And of course, you could make that even further and say that EK1 is 1/2 mv1 squared plus EP1 is mgh1, and that's going to equal our mv2 squared plus mgh2. Now it looks like a really large and ugly formula, but it really isn't. It's just made up of smaller parts that we've built on over the past few lessons. Now what do I mean by 1 and 2? Well, this is just different instances in a progression. So if I use that dropping example, for example, this would be my first instant. When it's dropping, I look at instance number 1, and then maybe I take a snapshot right here, and that would be instance number 2. Or if I asked you what the speed was at the ground, then my instance number 2 would be here. It doesn't matter where you choose your instances, as long as you have all the information. And that'll just become clear with more practice. So let's do an example. What is the total mechanical energy of a 0.12 kilogram ball that is traveling at a speed of 8.1 meters per second if it is 2 meters above the ground? So I would recommend drawing this. So I'm going to draw the ground, and it's a ball that is traveling at 8.1 meters per second. Here's my ball. The V1 is 8.1 meters per second. And we have a mass, 0.12 kilograms, traveling at a speed of that if it is 2 meters above the ground. And all it's asking for is what the total mechanical energy of it is. And this system has mechanical energy because it has potential energy and kinetic energy. So because you have both of those, or one of those, then you have mechanical energy. In this case, our EP is mgh, and our EK is 1/2 v squared. So we have 0.12 kilograms times 9.81 meters per second squared times our height of 2 meters plus 1/2 times our mass of 0.12 kilograms times our velocity of 8.1 meters per second squared. And if I plug all that into my calculator, 0.12 times 9.81 times 2 plus 0.5 times 0.12 times 8.1 squared, I get a total of 6.291 joules, or my total mechanical energy is equal to 6.3 joules. Excellent. Now this is a pretty light ball, so that's why it has such low energy. Let's try another one. If a soccer ball, so we have the mass of the soccer ball, is kicked with a mechanical energy of 55 joules, how high is the soccer ball when it was traveling at that speed? So, let's draw it out again. We have our soccer ball here, and it's going to get kicked. We have our mechanical energy. Now notice that I didn't put EM1, because this mechanical energy is true for the whole system. It doesn't matter where you look. If it's here as soon as it's kicked, if it's here, if it's here, if it's here, if here, 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 or here, they're all going to have the same mechanical energy. Mechanical energy is conserved throughout the system. So that's going to be important for the future. How high was it when it had a velocity? So somewhere in here we have a velocity 2 of 3.1 meters per second. And we know the mass is equal to 0.45 kilograms. And we want to find out what that height is here when that velocity happens. So let's try it. EM1 equals EM2. I would suggest getting into the habit of kind of creating a table, but that's just me. So those two have to be equal. I might even make myself some more room. Now EM1 was given to us at the very beginning, or you can call it EM2, it doesn't really matter. I'm going to call it EM1. 55 is equal to, then EM2. We don't have EM2 as a value, but we do have EK2 and EP2. So 55 is equal to 1/2 times mass times velocity squared plus mass times gravity times height. One-half, our mass of the soccer ball was 0.45, and the velocity was 3.1 squared plus m, mass is 0.45 times 9.81 times our height. Now we get into the algebra part. So I'm just going to, calculate, well, no I'm not. I'm going to, actually I like to use the variables first. Sorry about that. I will change this. Alright, so let's isolate for this 55, or this h here. In order to do that, we're going to get rid of this whole expression by subtracting 1/2 mv squared to both sides. You're going to get 55 minus 1/2 mv squared equals mgh. Now I need h all by itself, so I'm going to divide by mg to the whole thing, and I get h is equal to 55 minus 1/2 mv squared, all divided by mg. Now I can plug my numbers in. 55 minus 1/2 times 0.45 times 3.1 squared divided by 0.45 times 9.81. We get h is equal to 11.97 meters, or if we have two significant digits, 12 meters. So the ball will reach a total height of 12 meters. And that's all just based on the law of conservation of energy and using mechanical energy to solve. Okay, let's try another one. These are really popular questions, things being thrown upwards, because they're all in one direction and you'll expand on it in Physics 20. So if a hockey puck is thrown straight up, so I have my person, they have the hockey puck, and it's being thrown upward with an initial speed of 2 meters per second. We have mass of 170, but notice that that's in grams. We need it in kilograms. So 170 grams is equal to 0.17 kilograms. I just took the decimal and went over 3 times. We need to find out what the maximum height it reaches is. So up here, what is that height? Now one thing to notice is that you're definitely not going to be on the ground. So we're just finding the maximum height that it reaches from his hand. So the height is going to be measured here, only in this area, from here to here. So that's what that height means. It's the change in elevation. So let's create our little table. We know that EM1 is going to equal EM2. Now, why did I know I have to use energy? Well, not only are we just doing the energy lesson right now, but I know that when things are being thrown upwards and I have a bunch of information at the beginning, I'm going to use energy to solve for what's happening at the end, because I don't have any formula that's going to magically give me height from mass and velocity. Anytime there's height, really, you're going to use this formula for science 10. So EM1 is going to equal EM2. EM1 is made up of the first potential energy and the amount of kinetic energy we have at the beginning of the system. And this is number 1 here. I'm going to put that as my first system. Might make a different color. And this is going to be number 2 when it's at the top. So EM2 is made up of the potential energy at section 2 plus the kinetic energy at section 2. up here. Now, if you recall from before what a frame of reference is. Now, a frame of reference is just kind of creating a reference point and measuring everything based on that reference point. So we're going to make our reference point for our height at this part. So initially, we have 0 height. h1 is equal to 0 because we're measuring it to that reference point. So that would mean mg h1 is equal to mg times 0, which is 0. So, therefore, EP1 is equal to 0. EK1 is not equal to 0 because we have a velocity at the beginning. Now, EP2 is going to be mgh, and that's going to be whatever that h is up there. So we have potential energy. And then we get to EK2, which is equal to 1/2 mv squared. Now I'd like you just to throw up something that's light. Throw up an eraser. And tell me what you see at the top. How fast is it going at the very top of the peak? Hopefully you see that it stops. For just a moment, it stops at the very highest point. So anytime you have something where you're throwing something straight up in the air, at the maximum height, when it goes up here and here, your velocity is 0. That is huge. Anytime you throw something straight up in the air, at the very maximum point, the velocity is 0. So this whole thing goes to 0. So you're left with just 1/2 mv squared equals, that's v1, equals mgh2. Because this goes to 0 and this goes to 0. 1/2, now you can put your numbers in. Mass was 0.17. Our velocity was 2. And that's going to equal 0.17 times 9.81 times whatever our height is. Divide both sides by 0.17 times 9.81 on both sides. You get 0.5 times 0.17 times 4 divided by 0.17 divided by 9.81. You get 0.2 meters. So it only goes up 20 centimeters. So we could convert that because we only have one significant digit, so 0.2 is our final answer. Alright, let's do our last question here. The hockey puck is dropped from a cliff. So now we have a big cliff. We have a hockey puck here. And that hockey puck has a mass of 0.17 kilograms still. And that is 80 meters off the ground, or above the river. How fast is it going when it hits the river? So here, we want to find out what that speed is. Well, let's do the conservation of energy as well. Again, EM1 is going to equal EM2. And so EM1 is made up of EP1 and EK1. EM2 is made up of EP2 and EK2. If you look at EP1, we have obviously mgh1. EK1 is 1/2 mv1 squared. EP2 is mgh2, and EK2 is 1/2 mv2 squared. Now let's look at what we have. In our first section, again, I'm going to make this part 1 because that's where it starts, and this part is 2. At our first place, we have height, so we have EP, but it's being dropped, so it doesn't have an initial velocity. Our v1 is equal to 0. If you just drop something, it's not moving until you drop it. Then that potential energy gets converted to kinetic energy. Then at the very end, right before it hits the river, how high above the river is it? Well, it's pretty much 0. It's right at the river. So our height is equal to 0. But we do have a velocity, and that's what we're trying to solve for. So if we know that v1 is equal to 0, then this thing is 0, because it's multiplied by v. And then at the end, our height is 0, so we know that this part is 0, because it's multiplied by h. So you're left with mg h1 equals 1/2 mv2 squared. Now we want to isolate for v2 because we're asked how fast is it going when it hits the river. So let's isolate for v2. We're going to multiply by 2 to both sides to get rid of that 1/2. 2 mgh1 equals mv2 squared divided by m, and these m's cancel. You get 2gh equals v2 squared. Then you square root both sides, and you get the square root of 2gh equals v2. Which, now that we can put some numbers in it, 2 times 9.81 times 80, you get a velocity of 39.6 meters per second. Which, according to our significant digits, we have 3, 3, perfect. So that would be our final answer, 39.6 meters per second. Awesome. In our next lesson, we will discuss pendulums and graphing. Please practice your booklets for this stuff. It's not going to come easy at the beginning. I really wish we were in the class for this concept because it's very difficult, but please give it a shot and ask me questions if you have any. Have a great day.